Hi everyone, we are gonna answer grade 10 past paper questions. It is our first video about past papers. We are gonna carry on with you. So let's start our questions. Number one. First question in past papers, people, always question 1, multiple choice questions. 10 questions we have from 1.1 to 1.10. Let's start, let's answer our questions. First one, which one of the following physical quantities is a vector? So let's remember what is vector, what's a scalar quantity. First of all, people, scalar quantities, let's make our list. Scalar and vectors. People, scalar means if you have only magnitude, only number and unit. For example, time equals 5 seconds. As you see, there is no direction, nothing. Our first example for scalar is time. And then you can write speed, no direction. If there is no direction, you have scalar quantities. Speed, and then you can write distance. And then you can see our answer now. And then people, we can write what else? Mass, we can write temperature. Which one has no direction? We can write these examples. And then vector. Vector means with direction. You have something with direction, any quantity with direction. For example, force. You have an object here, and then one force acting F this way. As you see, direction is east. So force with direction. And then let's write our examples now. So vector quantities, they have direction. Just difference between scalar and vector, direction. All right. So force is our first example. And then we can write weight. Weight also force, but gravitational force. You know, weight, gravitational force is equal to mass times gravitational acceleration. And then another example, acceleration, positive or negative, so it has direction. And then velocity, we can add what is left, displacement. If you know this list, easy to answer these kind of questions. Which one is vector, which one is scalar? So let's answer our question now, 1.1. They're asking the people which one is vector. Answer is, what's that? Velocity. All right. We are not doing just answer question and carry on. So we are trying to explain people next time what kind of questions they can ask, how they are going to change these questions. So you are going to be ready for this kind of questions. Okay. So we are learning from question. That's the important point. Okay. We are learning from question. So if you know this list, you will give correct answer all these kind of questions. Next time, maybe they are going to ask you which one is scalar, and then, or which one is not a vector. You know, they can change questions like that. Time, speed, distance, mass, temperature, all of them scalar. Force, weight, acceleration, velocity, displacement, all of them vector quantity. When we go to next past paper, when you come to question 1.1, it's going to be easy for you. Let's continue. Next question, question 1.2 now. Okay, a characteristic property of motion at constant acceleration is that something. Change in position per unit time is constant. Change in velocity per unit time is constant. Velocity remains constant for duration of motion. Change in position remains constant for the duration of motion. What do you think? What is your answer? So I can give you time and you can try, or you can just stop video and try. So, but please try. All right. If you try, it's going to be much, much better for you. Before just getting answer, please try. So you can give your answer and then you can wait for our answer. People, now they said constant acceleration. We should know what is acceleration. Acceleration. What we know about acceleration, people? Acceleration is change in velocity per unit time. Acceleration is change in velocity. What is first option? Okay, let's see our options now. Change in position per unit time. What was it? That one is velocity. So V equals delta X. Delta X is change in position. Displacement, other name is displacement. Change in position per unit time is velocity. Delta T, sorry. Change in position per unit time, delta X over delta T is velocity. And then change in velocity per unit time, it is acceleration. This is our answer. So delta V over delta T. From formula, you can say definition also, people. As you say, change in form is change in velocity, delta V. Delta means change. Okay, change. If you just with more detail, if you want, V final minus V initial over delta T, or T final minus T initial also you can write. All right, this is our answer, people. Other options, let's check. If acceleration is constant, change in velocity per unit time is constant because this is acceleration. Okay, all giving you definition of acceleration. So change in velocity per unit time, if you know it is acceleration, easy to answer this question. All right, answer is B, 1.2. Answer is B. Let's continue with next question. Let's see what they ask. An equation of displacement, okay, delta X equals, yes, it is our equation of motion. Okay, equation of motion is given. They are asking you people, what is 1 over 2a delta t square? What's that? Please try first. Let's see, 1.3. What's your answer, people? I'm going to start answering, but you can try. You can stop video anytime, and then you can try. People, first of all, easy way you can use, if you have delta x here, so you can say this is delta x1, this is delta x2, and then answer is displacement, done. Or, just to make sure, people, let's use this part, what they ask, 1 over 2 a times delta t square, you can write delta t times delta t, right? Delta t times delta t, and then a times delta t is what? V, velocity, times delta t. And then what is left now? V times delta t. We know, people, V times delta t is delta x. Delta x means displacement. Other name is what? Change in position. Because symbol of position is x, delta x is displacement. Because of that, our answer is D. All right. So question 1.3 also done. Let's continue with next question. 1.4. Let's see what they ask. The gravitational potential energy of an object relative to the ground is dependent on the object's what? Speed, position, velocity, change in velocity. Please think about that and give your answer, people. Maybe you can share with me on comments. You can just say what you get out of 10 questions. Today we'll try to finish 10 questions from 1.1 to 1.10. All multiple choice questions. Question 1, we are finishing with you. Next video, we are going to carry on with question 2. I don't know how many questions we can answer, but we are going to carry on with question 2 next lesson. This lesson, multiple choice questions only. All right, please try. And then we are answering our questions. Question 1.4. Okay. Gravitational potential energy. So we know gravitational potential energy is stored energy. And formula is EP equals potential energy symbol is EP. EP equals M times G times H. What was the M? It is mass. Mass in kg. And then people, G is constant number. It is 9.8 meters per second square. It is gravitational acceleration. Gravitational acceleration 9.8 meters per second square, people. Just remember that. It is constant number. It is given in formula box. And then h is height. H is height. Height is formula, speed, position, or value of position. You can say height in meter. Height in meter. It is our, yes. Okay, this is our formula MGH. So you can just check what is here, people, height or position. Position, you can say which position, height or position, depends on position. H is, let's say, position in meter, height or position. We can say, as you see, people, the first option, what is our correct option, people? Position. Height or position, we can say. And because gravitational acceleration, sorry, gravitational potential energy depends on mass, gravitational acceleration, and height, and position, we can say. So, position in meters, answer is position. Next question. Let's continue with next question. Question 1.5 now. Okay, it's another topic. Waves now. Let's see. All electromagnetic waves have the same what? Same speed, same amplitude, same frequency, same wavelength. So what we said, people, from question we are learning. So if they said speed, what's that? We should know. Speed equals distance over time. We can write formula. Speed v, we can use small v, distance over time, delta t. Total distance also you can say. Amplitude, what was the amplitude, people, on waves? Amplitude is highest maximum displacement for waves, people. As you know, this is our rest position. Rest position, it means rest position. So for rest position, from rest to crest, people, it is amplitude. Maximum displacement for particles. As you know, particles going up and down for transfer waves. This is our amplitude. And then frequency. Frequency is number of waves per second. For example, here, if you say you have 1 second till this point, 1 second, as you see, you have half and positive, negative 1, and then another half, 1.5. As you see, in 1 second, 1.5 waves. So your frequency is 1.5 hertz Hz, or other unit, second power of negative 1. Okay, you can use any unit. Frequency is number of waves in 1 second. And then wavelength. Wavelength from crest to crest, from highest point to highest point, or from lowest point to lowest point. If you carry on like that, you can show wavelength. Wavelength is distance between two same points, for example, crest to crest, or from first point to another point, also wavelength distance. Let's show like this. This is our wavelength. This is symbol of wavelength, people. So we have just, now we know what is speed, amplitude, frequency, wavelength. So for electromagnetic waves, people, which one is same? Amplitude not same, of course, depends on loudness, depends on electromagnetic waves. Of course, amplitude different. Sometimes you can have different amplitude, different frequency. Of course, in 1 second you can have different number of waves. Wavelengths different you can have, but speed always same. Electromagnetic waves, speed of light, using speed of light, c equals 3 times 10 to the power of 8 meters per second. Okay, speed same for all electromagnetic waves. Please remember that. Speed is constant for all electromagnetic waves. So answer is A. Question 1.5, answer is A. But now you know amplitude. It is maximum height for point or for wave from rest position to crest. Frequency is number of waves in 1 second. Wavelength is distance between crest to crest, or distance between first point of wave to last point of wave, or from lowest point to lowest point, also wavelength, distance giving you wavelength. Answer is A, speed. All electromagnetic waves, they have same speed. Done. Let's continue, people, with next question, 1.6. Now let's see. Now they are talking about sound wave. Please check question, try first, and then we are going to show correct answer to you. In this question, people, they are asking you sound wave, just talking about sound wave. First of all, we have to know we have two types of waves, transfer waves and longitudinal waves. What's the difference between these two, people? Transfer waves, particles, just something like this, people, particles going up and down, and waves going left and right, or just opposite, but perpendicular. Particles maybe up and down, particles, and then transfer waves. So this direction for our waves, and then this direction for particles. So, for example, this particle now it's going up. And then when you come to here, another particle is going down. So particles just going up, direction of particles perpendicular to direction of wave. This one is transfer wave, all right. And then when you come to longitudinal wave, people, longitudinal wave, direction of particles, this one, and direction of wave, they parallel each other. Just going like this, we can show maybe with this one. Waves, and then another one. So we have compression. Actually, don't draw nice, sorry. Let's show with our lines, maybe just with particles. Some particles just close each other, people. Name is compression. And then particles interference, so this one, rarefaction. And then wait time just come together, another compression. So this one, all compression. When particles together, when you have a pressure for waves of particles, and another one, rarefaction, this one, and then you have another compression, longitudinal waves. Longitudinal waves, people, sound waves. Okay, sound waves. Example of sound wave is example of longitudinal waves, and then transfer waves, examples, water and light. Example. So if direction of particles perpendicular to direction of wave, you have transfer waves, example, water and light waves. And then if direction of particles parallel to direction of wave, so that one is longitudinal wave. For longitudinal wave, people, just think about air. Okay, in air, when you talk, you are just giving energy to particles. That one particle, let's show like this. In air, you have particles, people, for longitudinal waves. When you give energy to first particle just vibrating and giving to energy second one and third one, just so on and carry on, and last particle getting energy, and then particles moving left, right, and your waves also going left, right. As you see, they are parallel each other. And what just important thing, people, sound waves need particles. Okay, without particles, no sound. Okay, because longitudinal waves need particles. Remember that. All right, light doesn't need particles. Light wave doesn't need particles, but longitudinal waves need particles. Please remember that. Now, they said sound waves. transfer waves. Okay, sound waves produced are transfer waves. That one is wrong. This option is gone because we know sound waves, not transfer waves. And next option also gone because of transfer waves. And then C or D. Okay, two options left. Longitudinal waves require medium for yes, medium means just substance. It means particles. We need particles to move. Sound wave needs particle to move. Our answer is C. Let's see other option. Longitudinal waves, yes, it is correct wave, yes, but no medium, that one is wrong. Okay, because of that, we just remove option D. Our answer is C. I think it's okay. This one is just about wave. Let's continue with next question. Next question 1.7. Which one of the following statements is correct? All waves, all of them oh, sorry, we are going to try now. Let's wait a few seconds. Let's give time to stop video. So you can try first. Which one of the following statements is correct? All waves are transfer, all waves are longitudinal, all waves transmit energy, all waves travel through a vacuum, so it means they don't need particles, all waves. Let's see. Our answer is transmit energy. Our answer is transmit energy. Why? Let's explain. People, all waves transfers, that one is wrong, because we know water and light waves, they are transferred. But when you come to sound wave, it is longitudinal. So we cannot say all of them transfer. And then all of them longitudinal also wrong, because we know sound waves longitudinal, but light waves not. So it's not correct. And then we know sound for option D, we know people, sound needs particles. In vacuum, some of them, which one, for example, light can move, can go through, but sound cannot move. Because of that, answer is C. All of them transmit energy, all of them transfer energy, all of them carry energy, but not all transfer, not all longitudinal, not all of them moving without particles. Our answer is C. Let's go to next question, question 1.8 now. Yes, 1.8. Let's see what they ask. Direction of magnetic field. Okay, towards to what? South, north, positive pole, negative pole. Direction of magnetic field. Please try. All right, let's continue with answer now. So direction of magnetic fields, they are asking about direction of magnetic field. So we have to remember, let's draw a magnet here, and then let's show magnetic field direction. Direction of magnetic field always from N to S. Let's say this is NS. Direction of magnetic field from N to S. Let's draw it. Coming from N, we can show direction like this, from N to S. Another one, let's draw another line. This is our magnetic field. Symbol of magnetic field is B. So direction of magnetic field from N to S, we know that. And then, so for magnets, for magnetic field people, we are not using positive, negative. Option C, D gone already. And then they said towards to, okay, towards its south, because we know coming from N to S. Our answer is A. Question 1.8, done. Let's continue with next question. We're almost done for today. Let's continue with question 1.9. Okay, 1.9. An object which is charged positively. Okay, positively charged. What's going on? Please try. So we have 4 options. Please choose your correct option. Lost protons, lost electrons, gained protons, gained electrons. What is your correct answer? Please try. Let's answer now. Let's explain now first. First of all, people, charged object what does it mean, charge object? So if you have an object, let's show with X and the symbol. If there is no charge, we are using just saying 0. Okay, charge is 0. So if this object getting electrons from other object, this object, and getting negatively charged. For example, if you are getting 5 electrons, -5. So, because electrons, all electrons, they have negatively charged. And then, if this object losing electrons, you can say it is 0, how it's going to lose. But 0 means, people, number of electrons equals number of protons. For example, if we have 5, let's say 10 electrons, 10 protons. We have electrons, protons inside, but charge is 0. Okay, plus 10, minus 10, making 0 because of that. So if losing electrons, people, losing electrons, getting positively charged. Okay, so electrons negative. So now 5 electrons coming. When 5 electrons coming, your total electrons change to 15. So you have 15 electrons, and your charges, we can write it here, 15 electrons and 10 protons. Your charge is -5. And then this side, losing electrons, people, +5. If you're losing electrons, 10 minus 5, you have 5 electrons, and then you have 10 protons. As you see, people, we never touch number of protons because protons never move. All right, only electrons. You are getting charge with only electrons. You can think like this. For example, you have a class, you have friends, good friends, they are getting good mark. Some lazy learners coming to your class. If they come to your class average will decrease, right? Because they are lazy, their mark is not good. They mark not good, so they mark not good. Because of that, your class average decreases, people. Same thing with electrons. If they go, your class average will increase. So electrons negatively charged. When they come to any object getting negatively charged. If they go away from object, your object getting positively charged. Now, they're asking the people about positively charged. If they lost protons, no, because we know protons never move. And then lost electrons, yes, this is our correct answer. Gained protons, the protons never move. Gained electrons, if they are getting electrons, people, they are gonna get negatively charged, not positively. Because of that, our answer is B. Question 1.9, answer is B. Let's continue with next question, last question for today. Which one of the following is the unit of measurement of flow of charge? Okay, the rate of flow of charge. Please don't misunderstand. They are not asking you unit of charge. All right. They are asking you, people, the rate of flow of charge. Okay, please try. Question 1.10. Please try to get answer. So we have to remember something, people. First of all, now we can answer question because you stop video, you did try. Now it's my turn. The rate of flow of charge, is current. Symbol of current is I. Current equals charge over time. Okay, current equals, maybe we can write names also. Current equals charge over time. So they're asking you unit of current. Now it is easy, right? Because we know unit of current is ampere. And what is ohm? You know already, right? Ohm is units of resistance. Unit of resistance. And then volt, unit of potential difference. Because next time maybe they can ask about unit of potential difference. Unit of voltage also you can say, unit of voltage. And this is unit of current. This is our answer. Coulomb is unit of charge. units of charge. Some learners, they will choose this one because of this charge. Maybe they will say it is unit of charge, but please read question, people. The rate of flow of charge. So rate of charge, it means current equals charge over time. They're asking you unit of current. So we have done for today. See you next lesson with question 2. We are going to carry on with question 2.